Hi, in this video, I'm going to show you 3 examples on how to take a quadratic equation from standard form and move it to vertex form. We will be using the strategy called completing the square. Remember standard form, y equals ax squared plus bx plus c, and these examples are going to show you when our a value, that's the coefficient in front of the x squared, is 1. So looking at this first example here, we have y equals x squared plus 6x plus 7. That's in standard form, and we are being told to convert it to vertex form. So the idea of completing the square, like in the video before, is we're looking at how to make a square out of what we have right here. So my first step is going to be, I'm going to rewrite standard form, but I'm going to kick the c value out of the equation. Some teachers like to say kick it out of the kitchen. So I'm going to have a y equals x squared plus 6x, and then I'm going to do a blank, parenthesis blank, and put the c value way out at the end, kicking it out of the kitchen. So now when I look here, I have the makings of a perfect square trinomial like we practiced in the last video. So I'll start by taking the b value and dividing it by 2, and that gets me a 3. 3 squared is a plus 9. So what I've done is I've created a perfect square trinomial. But if I only do the plus 9 here, I've really changed the value of this quadratic function. It's no longer the same anymore. So I need to balance it out in this other blank right here. So what would balance a positive 9? It would be a negative 9. So now we're ready to rewrite this in quadratic form. So I have the y equals. Now this part of a perfect square trinomial, we practiced making it into the binomial. This case, it'll be the x plus 3. This 3 right here is what goes in there. And then how do I finish this off? A negative 9 plus 7 is a negative 2. I think of this a little bit as I have 7. I had 1, 2, 3, 4, 5, 6, 7 of those little squares. I needed 9 to make my square. You can see that right here. We needed 9. I am 2 short. I needed 2 more to fill that square, so that's where that negative 2 came from. So standard form to vertex form, y equals x squared plus 6x plus 7, and y equals the quantity of x plus 3 squared minus 2 are the same parabola. Oh, I keep doing that. I'm sorry. Let's try another one. Again, convert to vertex form. If you have something in standard form and you're asked to put it in vertex form, the strategy you're going to use is called completing the square. So let's think about what vertex form should look like. I'm going to kind of start a skeleton down here. I'm going to have a y equals my parentheses squared. I'll have an x here, and I need to figure out what my h and k are. So let's go back up to completing the square. First things first is I'm going to kick the c value out of the kitchen. I'm going to do blank, parenthesis, blank, plus 20. That c value's out. I'm going to take the b value and divide by 2. Negative 8 divided by 2 is a negative 4, and square that. Negative 4 squared is a positive 16. Now, if I only do a positive 16, I've really changed my parabola. It's something totally different. So I need to counterbalance that positive 16 with a negative 16. So now to take this perfect square trinomial and make it into this binomial, I'm going to use this value right here. The quantity of x minus 4 squared is the same thing as x squared minus 8x plus 16. And then I'm going to finish this off. Negative 16 plus 20 is a positive 4. Oops. So if I want to think about this on what I had to do to complete the square, it would say I had 20, but I only needed 16 little squares to complete that square. I had 4 extra. So that plus 4 sits there. I got the plus 20 from my C value, and the 16 that I needed came from that perfect square binomial. Let's try one more. I actually already did this for you. Completing to vertex form, if you take a look and copy this down, I did the b value divide by 2 and got -9. -9 squared was a positive 81. I balanced that with a negative 81. I took this perfect square trinomial and rewrote it as the quantity of x minus 9 squared. Negative 81 plus 100 is a positive 19. So if I think about this, it was, I had 100 squares, but I only needed 81 to complete my square. So this tells me I had 19 too many, or 19 extra. Because if I only needed 81 and I had 100, I had 19 too much. Then let's just take 1 minute and think about what the vertex form is telling us. This would have a vertex at 9, 19. What else would we know? We'd have an axis of symmetry at x equals 9. This vertex form tells us that our a value equals 1. So our pattern of change would be a 1, 3, and a 5. Since the a value is positive, this would open up and we would have a minimum value. Let's go back and look at example number 2, what the vertex form tells us. It would tell us we have a vertex at 4, 14. It would tell us that we have an axis of symmetry at x equals 4. Since the a value is a positive 1, we'd have a pattern of change of 1, 3, 5. Since the a is positive, it would open up and we will have a minimum value. So this is a little review from yesterday and from chapter 3. Going back to example 1, standard form tells us that we have a y-intercept at 0, 7, but vertex form tells me I have a vertex at -3, -2. I have an axis of symmetry at x equals -3. Since my a value is 1, I have a pattern of change of 1, 3, 5. Since a is positive, it's going to open up, and I'm going to have a minimum value. So it's nice. You get information from both standard form and vertex form.